Hello, welcome back to the lecture series on microeconomics. Last time we have seen how a competitive firm finds its short run equilibrium and equilibrium output level. Now we are going to study how the firm finds its long run equilibrium. So, if you remember our discussion on the profit maximization exercise, we have derived the first order condition which says that price has to be equal to the marginal cost. When we derived that first order condition, we did not assume whether it is a long run or it is a short run. Then we found that in the case of short run, firm equates the given market price to its short run marginal cost curve to find the equilibrium level of output in the short run, right. So, in the case of long run, we have to equate market price to the long run marginal cost. Now, if you remember, when we were discussing the theory of cost, we have drawn the long run average cost curve and the long run marginal cost curve. We have had some discussion on the derivation of the long run average cost curve, but we have not done so on the long run marginal cost curve. But as the marginal cost in both short run and long run are so important for firms decision making, let us now have a look at the long run marginal cost in greater detail. So, our first task would be to derive long run marginal cost from a graphical analysis. So, as usual, I will start with a diagram along horizontal axis. I am going to measure firm's output, and along the vertical axis I am going to measure various types of cost measured in monetary terms, right. So, first let us assume that our plant has a fixed short run plant capacity, and that will give rise to a short run total cost and corresponding short run average cost and short run marginal costs. So, as we know, the short run marginal cost curve passes through the minimum point of short run average cost curve. Okay. So, this is for a specific plant size. Now, if we have multiple plant size, so in that case, how to generate the long run average cost curve? Just to remind you that the long run average cost curve can be drawn as an outer envelope to this series of short run average cost curves. I have not drawn here more than one, just to make our graph less clumsy. So, the long run average cost will be something like this, an outer envelope of the short run average cost curves. So, every short run average cost curve will make tangency to this long run average cost curve at a particular point. It may not be necessarily the minimum point of the short run average cost curve. So, now let us see from here how to derive long run marginal cost curve of a firm. I have to draw your attention to a particular point here. So, as we have seen, the long run average cost or long run total cost curves are basically the outer envelopes of the short run versions. Here we will see, although that long run marginal cost curve is derived from or deduced from the short run marginal cost curve, it will not be envelope of the short run marginal cost curves. So, now this is what we are going to show graphically. Now, I take 2 points. So, one point could be here. So, let me denote this tangency point by point P. This has implication, that is why we need to name these points properly. Now, let me talk about some off tangency points, like this point here. Let me call this point Q, and let me take another point on the same short run average cost curve on the upward sloping segment of the short run average cost curve, and let me call this point H. Okay. Now, I will draw certain lines. So, I will draw a line, perpendicular line from point P on the quantity or output axis, and let that meet the quantity axis to denote a specific output level, say Q1. Okay. Now I will draw another perpendicular line, this time from my point capital Q, and let that denote output level Q2. Similarly, I will draw a perpendicular line to denote the output level, which is cap Q3. Right. Okay. Now my claim is that this particular perpendicular line PQ1, when it cuts the short run marginal cost curve at point say G, that is a point on the long run marginal cost curve. That is a claim. Okay, so let me write down my claim, and then we are going to have discussion to either prove or disprove that. So my claim is that take a point of tangency between short run average cost curve and long run average cost curves, then drop perpendicular line from that tangency point on the output axis right. Then 3, the intersection point of SMC curve and the perpendicular line is a point on the long run marginal cost curve. So this is the last part of the claim. If we get series of such intersection points, the locus of such points is the long run marginal cost curve, right. Okay. So now let me draw another short run average cost curve, which has this interesting feature that the minimum point of the short run average cost curve meets the minimum point of the long run average cost curve. So the scale size is such that minimum point for both these average cost curves are equal. So I am talking about a point like this, right. So for this also we will have a short run average cost curve So here is the corresponding short run marginal cost curve, right. Okay. So now in this case, of course, you can see that there will be no intersection if I draw a perpendicular line from this point of tangency between the short run average cost and the long run average cost curve, right. So this minimum point is another candidate point for the long run marginal cost curve. So now we can join these 2 points, and there will be other points as well, but let us not make this graph a cluttered one. So we can get something like this, right. That is the long run marginal cost curve. Now why is this so? For that we need to now discuss with these individual points Q and H and P. Okay. Let us now concentrate on the point Q. So at point Q, the short run average cost curve is higher than the long run average cost for that particular output level, right. So that output level is Q2. So now if I multiply, so for Q2 output level, right. Okay. So now if I multiply this short run average cost and long run average cost with the Q2 output level, then what do we get? We get short run total cost is greater than long run total cost for this output level, right. Now let us look at what does that mean in terms of the total cost diagram. So I will now draw another diagram which will probably be a recap of our cost analysis, but now this is necessary. So let me draw another diagram. So we measure output and cost, and then we can draw a short run total cost curve as an inverse S shaped curve like this, right. And we know that it will start from a positive point along the cost axis because of the fixed cost in the short run, but in the long run we assume that everything is variable. So there is no fixed cost. So the long run total cost curve will start from origin and it will make tangency at one point to the short run total cost, and then we get this long run total cost curve. Now from, if I want to match these two panels of diagrams, then let me name this point of tangency of short run total cost and long run total cost as the point P. Okay. Okay, fine. So now how to denote the point Q from panel A in this panel B diagram? So point P corresponds to Q1 level of output, right. Now if I want to talk about point Q, it will be on the short run total cost curve, but not on the long run total cost curve, because it is not a tangency point. Q is not a tangency point between the long run and short run average cost curves. So Q corresponds to an output level, say Q2, right. Now note at the slope of these 2 points Q and say R. Now let me talk about the slope. So, if you draw a line, straight line tangent to the point Q, we get the slope of the short run total cost, and if you draw a tangent, straight line tangent to the point R on the long run total cost, you get the slope of the long run total cost function. Now, you can certainly see that the slope at point R is higher than the slope at point Q. Now, what are these? So, the slope at point Q here is basically the short run marginal cost, right, for Q2 output level. And what is the slope at point R? So, that is basically my long run marginal cost for the same output level. Okay. So, what do we see? We see that short run marginal cost will be lower than the long run marginal cost to the left of point P, right. Okay. And that is the case we can observe from our graph as well. So, I would like to draw your attention to this intersection point G, right. Now, let us talk about the point H, which is also not a tangency point. So, at H what happens? Again we see the short run average cost is higher than the long run average cost for Q3 output level, right. And of course, if I multiply Q3 with the corresponding short run average cost and long run average cost numbers, I can write STC is greater than LTC for this output level, right. So, now in this diagram, how can we map this to? So, suppose I have this particular point H on the short run total cost curve, and now I am going to draw a vertical line so that I get my output level Q3, right, and this intersects my LTC here. Let me name this point. So, this is my H point, and this I can say point J, right. So, now I have to look at the slopes again. So, you can very well see that the slope at point J, slope of long run total cost curve at point J is flatter compared to the is less compared to the slope of the short run total cost curve at point H. So, I can write that short run marginal cost is higher, greater than long run marginal cost to the right of point P, right. So, we have derived the long run marginal cost curve graphically. Now, let us look at the long run equilibrium position of a firm, competitive firm. So, again we need to draw a complicated diagram to show the long run behavior of the farm. So, I measure quantity as usual here, and in this axis we are going to measure a lot of stuff. We are going to measure long run average cost, long run marginal cost, short run average cost, short run marginal cost, and then finally the market price P, right. Okay. So, now let us first start with the cost curves. So, I will start with drawing the long cauldron shaped long run average cost curve. Okay. And of course, by now we know that the long run marginal cost curve will pass through the minimum point of this long run average cost curve, but we will not draw this now, we will draw this later. Now, I am going to plot two different plant sizes. Okay. So, for each plant size there will be a corresponding short run average cost curve, right. Suppose this is the tangency point. Okay. So, this is my SAC1 corresponding to plant size 1. Now, there will be another large plant size, right, for which I will have another short run average cost curve like this, and I write this as SAC2. This plant size 2 is larger than the plant size 1. There will be a point of tangency here as well. Okay. Now, note that there are corresponding short run marginal cost curves which will pass through the minimum points of this short run average cost curves. So, let me draw them now. So, as we know that in short run it is only the positively sloped part of the marginal cost curve which plays the role in finding farm's equilibrium. That is what we are drawing, short run marginal cost 1, and similarly we can have a short run marginal cost SMC2, right. Okay. Now, let us superimpose the market price in this diagram and see what happens. So, let me assume that we have a market price which is P bar constant, and so this parallel straight line gives me market price which a competitive farm cannot change, and that is basically my P bar, right. So, P bar is the market price with which I start. Okay, fair enough. So, now how to find farm's equilibrium? Farm will find, suppose the farm starts with this plant size 1 corresponding short run average cost curves, and short run marginal cost curves are SAC and SMC 1s, SAC1 and SMC1. Now, we know that the farm will equate the market price to the short run marginal cost curve, right, and that is the farm's short run equilibrium. So, let me denote this by point E1. Now, we drop a vertical line on the output axis to figure out the output level, and let me say that this is Q1 output level. So, now this is basically farm short run equilibrium point. Now, let us going to talk about the distinction between the short run and long run for some time. So, farm produces in the short run, but it always plans in the long run, because in the long run all inputs are variable inputs, farm can choose them optimally, but in the short run when farm already has chosen some input bundle to produce some target output level, then there is some inputs which are fixed. So, basically a long run is basically a planning horizon for the farm. Okay. So, now let us look at this diagram that we have just drawn. We have seen that at market price P bar there is a difference between the short run average cost and the long run average cost because of the suboptimal plant size that the farm has chosen in the short run. We will continue with this discussion in the next lecture.